Welcome back to my channel. Today's topic is DBMS. In DBMS Part 2, we will study about attributes. Attributes are the descriptive properties which are owned by each entity of an entity set. Types of attributes. Simple attributes. Simple attributes are those attributes which cannot be divided further. Example, age. Composite attributes. Composite attributes are those attributes which are composed of many other simple attributes. Example, name and address. Multi-valued attributes. Multi-valued attributes are those attributes which can take more than one value for a given entity from an entity set. Example, mobile number, email ID. Derived attributes. Derived attributes are those attributes which can be derived from other attributes. Example, age can be derived from date of birth. Key attributes. Key attributes are those attributes which can identify an entity uniquely in an entity set. Example, roll number. Constraints. Relational constraints are the restrictions imposed on the database contents and operations. They ensure the correctness of data in the database. First is domain constraint. Domain constraint defines the domain or set of values for an attribute. It specifies that the value taken by the attribute must be in the atomic value from its domain. Second is tuple uniqueness constraint. Tuple uniqueness constraint specifies that all the tuples must be necessarily unique in any relation. Third is key constraint. All the values of primary key must be unique. The value of primary key must not be null. Fourth is entity integrity constraint. Entity integrity constraint specifies that no attributes of primary key must contain a null value in any relation. Fifth is referential integrity constraint. It specifies that all the values taken by the foreign key must either be available in the relation of the primary key or null. Closure of an attribute set. The set of all those attributes which can be functionally determined from an attribute set is called a closure of that attribute set. Keys. A key is a set of attributes that can identify each tuple uniquely in the given relation. Types of keys. First is superkey. A superkey is a set of attributes that can identify each tuple uniquely in the given relation. A superkey may consist of any number of attributes. Second is candidate key. A set of minimal attributes that can identify each tuple uniquely in the given relation is called a candidate key. Third is a primary key. A primary key is a candidate key that the database designer selects while designing the database. Primary key are unique and not null. Fourth is alternate key. Candidates key and that are left unimplemented or unused after implementing the primary key are called as alternative keys. Foreign key. An attribute X is called as foreign key to some other attributes Y when its values are dependent on the values of attribute Y. The relation in which attribute Y is present is called as the referenced relation. The relation in which attribute X is present is called as the referencing relation. Composite key. A primary key composed of multiple attributes and not just a single attribute is called a composite key. Seventh is unique key. It is unique for all the records of the table. Once assigned, its value cannot be changed. That is, it is not updatable. It may have a null value. Functional dependency. In any relation, a functional dependency alpha beta holds if two tuples having same value of attributes alpha also have same value of attribute beta. Types of functional dependency. Trivial functional dependency. A functional dependency X Y is said to be trivial if and only if Y set X. Thus, if RHS of a functional dependency is a subset of LHS, then it is called a trivial functional dependency. Non-trivial functional dependency. Non-trivial functional dependency. A functional dependency XY is said to be non-trivial if and only if X is not a subset of Y. Thus, if there exists at least one attribute in the RHS of a functional dependency, then that is not a part of LHS. Then it is called a non-trivial functional dependency. Decomposition of a relation. The process of breaking up or dividing a single relation into two or more sub-relations is called the decomposition of a relation. Properties of decomposition. First is lossless join decomposition. Consider there is a relation R which is decomposed into sub-relation R1, R2 to Rn. This decomposition is called lossless join decomposition. When the join of the sub-relation results in the same relation R that was decomposed. For lossless join decomposition, we always have R1 R2, R3 to Rn, where R is equal to R, where this sign belongs to is a natural join operator. That is, for lossless join decomposition, we always have R1 join operator, R2 join operator, R3 to join operator, Rn is R. Second, lossy join decomposition. Consider there is a relation R which is decomposed into sub-relation R1 to Rn. This decomposition is called lossy join decomposition when the join of the sub-relation does not result in the same relation R that was decomposed. For lossy join decomposition, we always have R1 join operator, R2 to Rn, subset R, where join operator is a natural join operator. This sign is a natural join operator. Normalization. In DBMS, database normalization is a process of making the database consistent by reducing the redundancy and ensuring the integrity of data through lossless decomposition. Normal forms. First normal form. A given relation is called in first normal form if each cell of the table contains only an atomic value, that is, if the attribute of every tuple is either single valued or a null value. Second normal form. A given relation is called second normal form if and only if relation already exists in one NF. No partial dependency exists in the relation. A to B is called a partial dependency if and only if A is a subset of some candidate key and B is non-prime attribute. Third normal form. A given relation is called in third normal form if and only if relation exists in two normal form, that is 2NF, and no transitive dependency exists for non-primitive attributes. A to B is called a transitive dependency if and only if A is not a superkey and B is a non-prime attribute. Boise chord normal form. A given relation is called in BCNF if and only if relation already exists in 3NF, that is third normal form. For each non-trivial functional dependency A to B, A is a superkey of the relation. This is the diagram. Thanks for watching. Like, subscribe and share for more videos.